Well, now we can do, we're going to do a consolidation and extensive exercises. We have here question question A1, let's write here 1, 2x to the negative 2 plus 2x to the negative 2, like that. Okay, there's a difference between these two terms, okay? 2x to the negative 2 and 2x within the bracket raised to the negative 2 are different. Now we can apply some law of exponents here. We do know that when we have a negative exponent, like when we say like a to the negative m, this is equivalent to write 1 over a to the m. Okay, so this formula can be applied for the two terms that we have here. Now for the first term, I'll write 2, and then it's x that is raised to the negative power of 2. So then I can write I'll write 1 over x squared. So it's 2 times 1 over x squared, and then plus here is the whole thing, 2x, which is raised to the negative power. This can be written as 2x to the power of 2, like that. Okay, all under 1. I say under 1 because there is an invisible. There will be, okay, all under 1. That's what the law says in the formula here. Okay, then we can simplify further. This will be like 2 over x squared plus 1 over 4x squared. Now that the denominator are okay, now that we have a fraction here, we can try to make the denominator common. Okay, because to add fraction we need to set the denominator common. To do that, I must multiply here by 4, because if I multiply the denominator here by 4, they will be common. But if I multiply by 4 at the denominator, I must multiply also the numerator by 4. Okay, to make the fraction even, and then this will be like 8 over 4x squared plus 1 over 4x squared. Then we can, now that we have like common denominators, we can solve this by combining like terms. Okay, we can just say 8 plus 1, which is 9, over 4x squared. That was question 1. Now we can do question 2. The question says 2x to the power of 0 plus 2x to the power of 0 equal what? Now, another law of exponent I want to write over here is like, we do know that any number raised to the power of 0 is equal to 1. That's a definition. It's a corollary or corollary definition maybe of exponents. So now, any number raised to the power of 0 equal 1. Then over here, we'll have like 2 multiplied by 1 plus 1, okay, because the whole thing, the 2x within the bracket to the power of is just 1. So this will be 2 plus 1, which is 3. And then that was question 2. Okay. Now we can simplify question 3, a to the negative 1 plus b to the negative 1. So question 3, a to the negative 1 plus b to the negative 1. So to simplify this, we need to apply the law of exponent I wrote earlier. So I'll say this will be like 1 over a to the 1 plus 1 over b to the 1. Okay. So now that I have fractions, to add a fraction, I must make the denominator common, meaning over here I'll times by b, I'll times there also by b, and there I'll times by a, I'll times there also by a. Okay. First, to make the denominator common. Second, to keep the fraction even. So to make it common, I times here by a, by b. So I times there by a. So we have like b times this ab. That's also ab. And then to make the fraction even, if I times the denominator by b, I must times the numerator by b also. I times here by a, I must times there by a. So this will be equal to b over ab plus a over ab. Now that the denominator are common, we can add the numerator. We can say a plus b over ab. That's the answer here. Okay. Question 4. It's a plus b all raised to the -1. Okay. Over here, we can apply that law of exponents we learned. Okay, I may rewrite it over here. That any number raised to the negative power can be just 1 over a to the m. Okay, so this will just be a plus b all under 1. I could put brackets, but I don't have to because the power is just 1. And then question 5, what does it say? 3011 minus 3012 raised, so we have like 3011 minus 3012 all to the power of 3013. Then this will be -1 to the 3013, and then this the sign of this space is negative and exponent is uneven or odd. Okay, if we have like an odd exponent here, odd number exponent as exponent, the base will keep its signs. Okay, and it's gonna be negative, and then 1 to any power is still gonna be 1. So the answer is -1. Question 6. We can do question 9. Question says -4x² y to the power of 2 multiplied by -4x² y to the power of 3. So this will be, we're going first to, okay, it's going to be -4x² y. So we raise this to the power of 2, we raise this to the power of 2, we raise that also to the power of 2. Another product for the other brackets will be on the right side -4x² y. I'm going to raise each of this to the power of 3, that to the power of 3, and that to the power of 3. And then this will make 16 x to the 4, y to the 2, multiplied by -64. Okay. X to the 6, y to the 3, and then over here I can't really do, okay, if I want to be strict here of not using a calculator, over here I can do what 16 can be written as 2 to the power of 4. Okay, x to the power of 4. Okay, let's combine here. Maybe before I combine, let me write all this. And then the 64 can be written in terms of its prime factor. 64 will be 2 to the power of 6, and then x to the power of 6, y to the power of 3. Now that all are in terms of the prime factor, I can just combine all this. Okay, remember that -2 to the 64 is like writing, let me write it like this. It's the same as if I wanted to write -1 multiplied by 64. Okay, x to the 6, y to the 3. Now this can be written as to the 4, x to the 4, y to the 2 multiplied by -1 times 2 to the 6 times x to the 6, and then times y to the 3. So now we can combine like terms. I mean, yeah, here we have like, I mean, terms, I mean, we can combine common bases like 2 to the 4 and 2 to the 6 makes 2 to the 10, multiplied by x to the 10, multiplied by y to the 6, okay? And 2 to the 10, you know, I know the value of 2, that makes 1024, x to the 10, y to the 6, okay? Question 6 here. Question 6 was 3x to the 4 raised to the power of 2 multiplied by 2 x to the 2 all to the power of 4. Okay. In this case, we say that if you have like ab to the power of m the power of m is for A and also for B. Now, we can do, so this means like, it's gonna be like, let's say here, 3 to the power of 2, x to the power of 4 to the power of 2, and then, so it's gonna be like 3 to the power of 2, and then x to the power of 4 raised to the power of 2, multiplied by 2, and then here we can apply this law, okay? So, oh, not this one, but this, the following, a to the m raised to the n equal to a to the m multiplied by n. So, you can apply that one. Then this will be x to the power of 8. Then that makes what, 9 multiplied by x to the 8 multiplied by 2x to the 8. Now that we have 9 and 2, 9 and 2 makes 16, actually 18. And then here, common basis, what we do when we have a product of common basis, we add, okay, the exponent. So we do 8 plus 8, which is 16. So 18 to the power of 16. That was question 6. Now we can do question 7. So that's 3x to the power of 4 to the power of 2 plus 2x squared to the power of 4. So this makes what? We times here, we times this, and then that makes 3 to the power of 2, and then it's gonna be x to the power of 4 raised to the power of 2 also. Okay, so the power of 2 is for the 3 and also for the x to the power of 4, and then plus 2 is outside the bracket, so it's not we're not gonna raise it to the power of 4, and then x to the power of 2 raised to the power of 4. Then here we can just times exponents like that. Okay, over there I don't need to rewrite this. We can just say times exponents. That will make x to the power of 8. So this makes like 9 x to the power of 8 plus 2 x to the power of 8, which means 11 x to the power of 8. That was question 7. Okay. Now we're going to do question 8. Question 8 says that 3x cubed plus 3x cubed raised to the power of 3. So over here we can add what is within the bracket because they're all expressed in terms of x cubed. Okay, so we can just do 3 plus 3, which is 6. So that makes 6x cubed raised to the power of 3. And then the power of, it's going to be like 6 to the power of 3, and then x to the power of 3 to the power of 3. Then this makes x to the power of 3, 6 to the power of 3 is 216. And then that makes x to the power of 9. Okay. Well, question 9, what you have, the question says that negative 4x to the power of 2 y all to the power of 2 multiplied by negative 4x squared y to the power of 3. Now this will be what? I will write it like negative 4 to the power of 2 x to the power of 2 y to the power of 2 negative 4 to the power of 2 x to the power of 2 y, no, negative 4 to the power of 3, the power is 3 now, there the power is also 3, and y also the power is 3. Now I can substitute, we have like negative 4 will be raised to the power of 2, x squared will be raised to the power of 2, y will be raised to the power of 2, negative 4 to the power of 3, x squared to the power of 3, and then y to the power of 3. Now, this will be what? Negative 4 to the, because I'm going to times this, I prefer to, okay, let's just write, that makes positive 16, that x to the power of 4, y to the power of 2, negative 4 to the power of 3 is negative, multiplied by negative 64, multiplied by x to the power of 6, okay, because we're going to times the exponents here, and then y to the power of 3. Then we can write them in terms of the prime factor. 16 can be like 2 to the power of 4, multiplied by x to the 4, y to the 2, y to the 2, okay, times negative 64. In terms of its prime factor, I can write it like, it's like negative 1 times 64. You know, that's negative 64. It's like negative 1 times positive 64. It makes negative 64. So now multiply by x to the power of 6, y to the power of 3. I can combine like terms here. You see that's x and that one, this y squared and y cubed there. And then we have like 2 to the power of 4 multiplied by x to the power of 10, okay? 4 plus 6 makes 10, multiplied by y to the power of 5, multiplied by negative 1, and times 64 is 2 to the power of 6. Then we can combine 2 to the power of 4 also, and 2 to the power of 6 makes 2 to the power of 10, multiplied by x to the 10, multiplied by y to the 5, multiplied by negative 1. So 2 to the power of 10 is 1024, multiplied by negative 1 will be negative that, and then x to the power of 10, y to the power of 5. So that's question 9. Now we can do a question 10. The question says 12 x to the negative 2, y to the 4, all over 18 x to the negative 6, y to the 7, all raised to the negative 2. Now to solve this, first of all, when we have a negative exponent like this, we can apply this law of exponent that says if you have like a over b raised to the negative m, to the negative m, this can be written as b over a to the positive m. Okay. We can apply that law. Okay, but before doing that, I prefer to solve what is at the denominator, what is within the fraction. Okay, and then I can apply this law afterward. Or we can start by applying that law and then simplify what's in the bracket. But I prefer to simplify first what is within the bracket, then we can do that property. Now, we can see that 12 and 18 have a common factor, which is 6. So if I divide 12 by 6, I'll get 2. If I divide 18 by 6, I'll get 3. So you can simplify these two. So here we have like 2, and then x to negative 2, I'll leave it like that. I'll move this negative exponent up, okay? There, that makes times x to the positive 6, and then multiply by y to the 4. I'll move that makes y to the 7. It's just like over 1, okay? All raised to the power of negative 2. I say 7, I mean negative 7. Okay? These one were moved up. Then this will make what? We can combine some bases. So we have like 2. That makes x to the positive 4 multiplied by y to the negative 3. Okay? Over 1. I can say over 1, or I cannot say over 1. It's still okay. So to the negative 2. Then I don't need a negative exponent, so I can move back this at the denominator. So this will be like 2x to the 4 over y to the 3 raised to the negative exponent 2. This is when then I can apply this property. Okay, this will be y to the 3 over 2x to the 4 raised to the power of 2. Then we can simplify this further. This will be y to the 6, and then 4x x to the 8. Okay, that was question 10. Okay, let's double check. Oops, sorry, I didn't write the 3 at the denominator. It was over 3. Over 3 was there. When we simplify, it's 3 was there, the denominator. My apologies. So 3 were there. 3 were here. If I move this 3 is gonna be there, and if the reverse is gonna be there, so that makes 9, 3 squared 9. So the answer is 9 of 9 y to the 6 all over x 4x to the 8. That's question 10, and then we can do question 11. It's 32 to the power of 2 times 25 to the power of 3 all over 100 multiplied by 8 to the 4. Now, we can solve this, okay, by writing each of the numbers here in terms of the prime factors, okay? So 32 in terms of prime factor is 2 to the power 5. If you're unsure, you can apply the factor 3, the factor 3. Remember, we said like it's like 32, okay, by 2, 16 by 2, 8 by 2, 4 by 2, 2 by 2, 1, and then we say 1, 2, 3, 4, 5. So it's 2 to the power 5. Or we can use this as a calculator. If you do, for instance, 32, okay, and then press equal button, and then press the shift button, this button, and then press effect button, and then tells you what it is in terms of its prime factors. So same also 25 is 5 squared. That's 5 squared. And the 100 in terms of its prime factor will be 2 squared and 5 squared. Okay, you can check the calculator. You press the 100 equal shift effect. You see, 2 squared times 5 squared. And then 8 in terms of its prime factor is 2 to the power of 3. Then we can simplify this with times exponents. Here also with times exponents. There it will be like 2 to the 10 multiplied by 5 to the 6 all over 2 to the 2 multiplied by 5 squared multiplied by 2 to the 12. Then this makes what? 2 to the 10 multiplied by 5 to the 6 all over 2 to the 14 multiplied by 5 squared. This will be what? We can simplify this. Look at the denominator, the exponent is 10, there it's 14. So we can do 14 minus 10, which is 4. Okay, so we're going to do okay, I'll list here the 2 ways of solving, the 2 ways we can solve. I don't want to call it traditional, maybe I can call it like that. So if I say I keep 2 to the 10, okay, because the bases are all in terms of the prime factors, I can just write 1, 2. I can write 1, 2, okay, and then say the power, the numerator is 10, and then this there the power is 14. So I say minus 14 because it is at the denominator, multiplied by 5, 6, and then minus 2. And this will be 2 to the negative 4, 5 to the 4. Okay, and then this will be what? 5 to the 4 over 2 to the 4, or can be written as 5 over 2 to the power 4. 5 over 2 all to the power 4. We can write it this way, or we can also just look at where the highest exponent is. If the highest exponent is at the denominator, like in this case, I'll keep 2 at the denominator, and then I'll do 14 minus 10, which is 4. Okay, and then over here, the highest exponent is at the numerator, and then I'll do 6 minus 2, and I keep 5 at the numerator. So it's gonna be like 5 to the 6 minus 2 over 2 to the 14 minus 10. I'll repeat. I look here, the highest exponent is at the denominator, so I keep 2 at the denominator. I do 14 minus 10. Over here, the highest exponent is at the numerator. I'll keep 5 at the numerator, and then I do 6 minus 2. So this will be 5 to the 4 over 2 to the 4, which is 5 over 2 to the power of 4. Excuse me, the power of 4. That was question 11. Now we can do question 14, question 12. 8 to the 2 over 3, okay, multiplied by 2 to the negative 3 to the power of 1 over 3, all over 16 to the power of a half. Then we can write these in terms of their prime factors. So I write, okay, we have 2 over 3 there, and then 8 in terms of its prime factor is 2 to the power of 3, okay? Over here, we can just times the exponents, as the law of exponents says. That makes 2 to the negative 3 times 1 over 3 is just negative 1. And then 16 in terms of its prime factor is 2 to the 4. So this will be, over here, we times also the exponent. So that makes 2 to the 2, because 3 times 2 over 3, we cancel, we have 2 to the 2, multiplied by 2 to the negative 1. And then over there, we will have like 2 to the power of 2, because we times the exponent here. 4 times a half is just 2. Then we can continue solving. We can just simplify this and that. And then the answer is 2 to the negative 1, which can be written as 1 over 2. Okay. And then can do question 13. Question 13, what we have, 9 to the x minus 1 multiplied by 24 to the x plus 1 all over 27 to the x multiplied by 8 to the x. So what can we do here? I'll keep it like to the x minus 1 multiplied by 24 to the x plus 1 all over 27 to the x multiplied by 8 to the x. So 9 is 3 squared. 24 in terms of its prime factor is let's check the calculator. If I write 24 equal, okay, sorry, 24 equal shift and then fact 2 to the 3 times 3. So that makes 2 to the 3 times 3, and 27 is 3 to the 3, and then 8 is 2 to the 3 also. So this will be we're gonna times the exponent. Okay, remember here, this when you times it's not gonna be 2x minus 1, it's gonna be 2x minus 2, because we do 2 times x makes 2x, and then 2 times negative 1 makes negative 2. So it's gonna be like 2x minus 2. Okay, times over there, the power is for both 2 to the 3 and 3. So it's gonna be like 2 to the 3 multiplied by x plus 1, okay, multiplied by 3 to the power of x plus 1, okay, all over there it's gonna be 3 to the 3x multiplied by 2 to the 3x. Now that we did write everything in terms of the prime factors, we can just combine this. I'm gonna write 1, 3 over here. I look here, the base here is 3. I'm gonna write it 3 there, and then I'll do 2x minus 2, and then plus x minus x plus 1, and then this one is also another, oh sorry, this is also another base of 3, but the exponent is at the, but it is at the denominator, so I'm minus 3x here, and then I'm gonna write also 1, 2, only 1, 2, and then the exponents are 3x plus 1, which is at the numerator minus 3x. Then this makes what? 3 to the, okay, 2x plus 2x minus 3x, 0. And then negative 2 plus 1 makes a negative 1. So here the exponent is a negative 1 multiplied by, over there, I could just calculate it. That makes like this times that, this times that. So it's going to be 3x plus 3, and then minus 3x. So multiplied by 2 to the 3, because 3x and negative 3x can simplify, they all cancel out. And then 2 has a positive power, keep it in the numerator, it's going to be 8. And then 3 to the negative 1 has a negative power, I move the numerator, it's going to be 3. So that was question 13. Now let's do question 14. 14, what do we have there? 2 to the x plus 2 plus 5 multiplied by 2 to the x minus, not minus, but plus 2 to the x all over 5 multiplied by 2 to the x. Okay, now we can break what is at the numerator, 2 to the x times 2 to the 2 plus 5 to 5 multiplied by 2 to the x plus 2 to the x there, all over 5 multiplied by 2 to the x. So this will make what? 4 multiplied by 2 to the x plus 5 multiplied by 2 to the x plus 2 to the x, all over 5 multiplied by 2 to the x. So what does it make here? 4. Okay, this is a variable. We can call it as, we can call it a letter, any letter, let's call it n. We can call it n. Okay, so we have like 4n plus 5n plus 1n, because there's an invisible 1 here. This makes a 10n, like 10 to the 2x over a 5 to the 2x. Then we can simplify this and that. That's equal to 2. That's question 14. Question 15 then should be what? Let's do 15. X to the 4 raised to the negative 1 over 8 multiplied by x to the half to the power of 3 multiplied by x to the 1 over 3 to the power, I need to check also, that was to the power of negative 1, and then all over x to the 3 to the 1 over 3, I mean, to the power of 2. Now let's simplify this. That makes x to the negative half multiplied by x to the 3 over 2 multiplied by x to the negative 1 over 3 all over x to the 2 over 3. Okay. What can we do here? The fact that we have common denominator over here, we can combine these. So we're gonna do negative 1 plus 3, which makes 2, and 2 over 2 is just 1. That makes x to the power of 1 multiplied by, I can move this one at the denominator, okay? So x to the 1 over x to the 2 over 3 multiplied by x to the 1 over 3, which makes over there we can also combine. Okay, same basis, we combine we combine the exponent, so that makes x over 2 over 3 plus 1 over 3 just 1, so x to the power of 1 also. which is just equal to 1. So that was question 15, and then we can do question 16. Um, okay, right, like this, question 16. The question says that 121 to the x, okay, minus 4 all over 11 to the x plus 2. Now, what can we do here? 121 is a square number, okay? So is 4 over 11 to the x plus 2. 121, a square number is the square of 11, so I can write here 11 squared, and then there are also 2 squared, okay? So we can do something here. I want to move, switch x, the powers x and 2. This will be 11 to the x, okay, to the power of 2, like that, okay, plus 2 squared. So I have like not plus but minus minus 2 squared all over 11 to the x plus 2. So this will make what? Difference of 2 squares, okay? So we can write here 11 to the x minus 2, and then 11 to the x plus 2 all over 11 to the x plus 2. Then we can simplify these two, and then the solution will be just 11 to the x minus 2. So that was question 16. Then we can do a question 17, which says 4 to the x minus 3 times 2 to the x plus 1, okay, minus 27 all over 2 to the x plus 3, okay. I prefer to write each numbers in terms of the prime factors. 4 is a square number, so I can write it like 2 squared, so that makes 2 to the 2x, minus 3 multiplied by 2 to the x, multiplied by 2 to the 1, minus 27, which is 3 cubed, all over 2 to the x plus 3. Then, what does it make? At the numerator there, we have 2 to the 2x can be written as 2 to the x to the power of 2 minus 3 times 2 to the x. Okay, over here, we can do 3 times 2, that makes 6 times 2 to the x minus 27 all over 2 to the x plus 3, okay? And then this will make what? The basis here, we can call it n. We can call this one n, and then this will be n squared. Yeah, it's going to be like n squared minus 6n minus 27 all over n plus 3, okay? So it looks like that. Then we can, since we transform it into a quadratic trinomial, we can factorize. There, it's going to be like, all right, n here, close there, open bracket, n there, close there, all over n plus 3. So what I can do, I'll write 27 here, negative 27 here, the last term. Okay, I'm trying to factorize this. If you struggle with factorization, we have like a full set of exercises dedicated on factorization, a playlist. You can go further to revise, okay, but this is how we do factorize quadratic trinomial. So you take the last term, negative 27, write it here, and then I'm going to list all the factors of 27, preferably in ascending order. So they're like 1 and 27, 3 and 9, and that's all. Then I'm gonna look at which couple among the factors of 27 will make a sum equal to the coefficient of the middle term, -6. You can see that 1 and 27 cannot make 6, but 3 and 9, yes, they can. They can make -6 if this is a positive 3 and that is -9, because 3 minus 9 makes -6. Then you can place positive 3 and -6 wherever you want to place it. Then you can simplify that and that, and then the answer is just n minus 6. Now we can substitute. Remember that initially we didn't have n, it was 2 to the power of x that we call n. We can substitute by its value. That makes 2 to the x minus 6. That's the final answer. Not minus 6, but minus 9, sorry. Minus 9. Minus 9. Okay, so over here, it makes 2 to the x minus 9. Then the next question will be question 18. 50 to the power of x minus 10 to the power of x all over 10 to the power of x minus 2 to the power of x. Okay, now let me tell you something here. Don't say 50 to the power of x minus 10 to the power of x equal to 40 to the power of x. Okay, because the bases are not common. You cannot just minus 50 and 10. I can give you an example. Imagine that x was, let's say, if I say, let's say 5 to the power of x, no, 5 to the power of 3 minus 2 to the power of 3, for instance. Okay, if you say this is 5 minus 2 is 3, 3 to the power of 3. Okay, let's say if you say something like that, let's check. If you do 5 to the power of 3 is 125. 2 to the power of 3 is 8. 125 to the power of 3 minus 8 is 117. While 3 to the power of 3 here is 27. You see that they're not the same. So we need to have some base to add or subtract these exponents. Then what can we do in this case? We need to write each of the bases in terms of the prime factors. Okay, 50 in terms of its prime factor will be on a right here like this, bracket that to the x minus bracket that to the x. Over there, bracket to the x minus, okay, 2 to the x, I can just leave it as 2 to the x because 2 is already prime factor. 50 in terms of its prime factor is 2 squared times 5 squared. No, it's 2 times 5 squared. 2 times 5 squared, you can check in the calculator. 50, you write 50 equal shift and then press fact. It makes 2 times 5 squared. Then also in terms of its prime factor is like 2 times 5. And then that also 2 times 5. And then this would be 2 to the x times 5 to the 2x, okay, minus 2 to the x times 5 to the x. This exponent here, this exponent is for 2 and also for 5 squared, so it makes this all over 2 to the x times 5 to the x minus 2 to the x. Then we can take a common factor here. The common factor for the numerator, you see we have 2x and also 2x there. So we can take 2x for common factor. And then we have 2x here and then 1x there. I can take also 5 to the x for the common factor. And then there we will left with 5 to the power of x minus 1, okay, all over, again, Over here, I can take 2 to the x multiplied by 5 to the x for common factor. No, only 2 to the x, which is the common factor here. Because it is over here, it is also over there. We can take it for the common factor. And then there is going to be 5 to the x minus 1. Now that we can simplify, 2 to the x and 2 to the x. We can simplify 5 to the x minus 1 with 5 to the x minus 1. And then the answer is just 5 to the x. Okay. That was question 18. The last question in this last question of question 8. Thank you.